Welcome to another deep dive. This time, we're going to tackle something that'll really make you think about the universe, how we see it and all.
Oh, this is going to be good.
So we've got this research paper, Cosmic Deceptions Due to Peculiar Motions.
Okay, yeah.
And it asks, what if everything we think we know about the universe is a little bit off? What if it's not some crazy new physics, but just because we're, moving through space?
It's a pretty wild idea, right? Like that our own motion could be distorting our view of the cosmos. But it's not a new idea, In science, we've been grappling with this for centuries, the idea that our perspective can play tricks on us, create illusions about the world.
Yeah, totally. I mean, we've all had that moment sitting on a train and feeling like the train next to us is moving when it's actually us pulling away from the station.
Exactly.
But hold on, we're not talking about trains here, are we? We're talking about galaxies, like the whole universe.
That's right. This paper takes that basic concept, that feeling of relative motion, and scales it up to, cosmic proportions. It's saying that our galaxy's movement, particularly how it's moving compared to the cosmic microwave background, the CMB could mess with our understanding of how the universe is expanding.
Okay, hold up a sec. Just to remind everyone, the CMB, that's the leftover radiation from the Big Bang, right?
Yeah.
So how could our movement compared to that affect how we see the universe expanding?
Well, think of the CMB as the best stationary point we've got in the universe. Like, if the universe was a giant highway, the CMB would be that one rest stop that's actually, not moving. It's our cosmic reference point.
Got it.
But just like cars on a highway, galaxies aren't just sitting still. We're all moving, and we all have what's called a peculiar velocity, which is basically how fast and in what direction we're moving compared to that CMB rest stop.
So it's like we're trying to judge how fast other cars are going while we're zooming down the highway ourselves.
Exactly. And just like in that car analogy, our own motion can totally mess with what we see. This paper says this distortion could be so huge that it makes the universe seem like it's expanding faster than it actually is.
Hold on. Are you saying that this whole idea of the universe speeding up, this dark energy that's supposed to be driving it all,
Yes.
could that be because of how we're moving through space?
That's one of the big questions this paper is tackling. It uses this framework called tilted cosmologies to look at how what we see changes based on, where we're standing, so to speak. And let me tell you, the results are pretty mind-blowing.
Okay, tilted cosmologies. That sounds pretty heavy. Can we break that down a bit? What do they even mean?
Well, it means we're kind of admitting that our view from Earth, hurtling through space like we are, isn't exactly the perfect objective view. Tilted cosmologies is a way to take that tilt into account, the tilt in our observations caused by our motion. Imagine you're trying to measure how fast a train is going, but you're on a platform that's also moving. You're not going to get the right answer, are you?
Oh, I see. So it's like we're on a moving platform trying to measure the universe's expansion, and that's throwing everything off.
That's a great way to put it. And here's the thing, this tilted view has some big implications. For example, this paper shows how our own peculiar velocity could totally mess with something called the deceleration parameter.
Okay, deceleration parameter. That's a mouthful. For the folks at home, what does that even mean?
Think of it like this. The deceleration parameter tells us if the universe is hitting the brakes, if its expansion is slowing down.
Right.
But the thing is, if you're moving, your measurement of that deceleration parameter is going to be different from someone who's, not.
So depending on where we are and how fast we're moving, we might think the universe is braking when it's actually what's speeding up.
Exactly. And the paper even goes into how this effect could be different depending on if the overall movement of galaxies in our neighborhood is contracting or expanding. It really shows how what's going on locally can totally change how we see the bigger picture.
Whoa. So are we basically driving around with a broken speedometer and thinking we know how fast the universe is going?
Kind of, yeah. And that brings up a whole bunch of other questions, like how much is our peculiar velocity messing with our understanding of other things in the universe?
This is blowing my mind already, and we're just getting started.
Yeah, there are a lot of really interesting questions that come out of this. And you know what we haven't even talked about yet?
With that?
One of the craziest implications of this whole thing, what if what we think is dark energy
Okay, yeah.
is actually just an illusion
Whoa!
caused by how we're moving?
Hey, Grace, dark energy, that mysterious stuff that's supposed to make up, most of the universe and is making it expand faster and faster. You're saying that could be because of our peculiar velocity.
It sounds crazy, but the paper makes a pretty strong case. And get this, it actually uses data from these bulk flow surveys.
Bulk flow surveys.
Yeah, they're basically studies of how galaxies are moving on these huge scales. And this data shows that the kind of distortions we're talking about, they're not just like theoretical, they could actually be happening right now in the observable universe.
So there's actual evidence to back this up.
There is, and it gets even wilder. The paper shows how these distortions could even make it look like the universe has crossed this thing called the phantom divide.
Phantom divide. That sounds kind of scary. What is that exactly?
It's basically this theoretical line in cosmology where the universe's expansion doesn't just accelerate, it accelerates faster and faster all the time.
So like hitting the gas pedal and never letting up.
Yeah, exactly.
Yeah.
And what this paper is saying is that we might be seeing signs of this phantom energy when it's really just our own motion messing with our observations.
This is seriously mind-blowing. I mean, if we can be fooled by our own motion into thinking the universe is doing something, it's not, how can we ever know what's real? Is there any way to, like, double-check the universe and see if we're getting the right picture?
That's the million-dollar question, right? But luckily, the paper gives us a possible way to test this whole idea. It suggests looking for a specific pattern in how the universe's expansion looks different in different directions.
So we're not just talking about an average expansion rate anymore, but, like, how it might be different depending on which way we look.
You got it. And this is where it gets really cool. The paper talks about this thing called the deceleration tensor. It's basically like a 3D map of the universe's expansion.
Oh, okay. So instead of just one number telling us how fast the universe is expanding, we have this map showing us how it might be different all over the sky.
Exactly. And here's the kicker. If our peculiar velocity is really messing with our observations, this map should show a really specific pattern, a kind of dipole.
A dipole, like two opposite poles. What would that tell us?
It would mean the universe looks like it's expanding faster in one direction and slower in the opposite direction, kind of like the dipole we see in the cosmic microwave background, which we think is caused by our motion relative to the CMB.
So finding this dipole in the expansion map, that would be like a smoking gun, telling us that we're not seeing the real picture because of how we're moving.
You nailed it. And another thing, this dipole, it should get weaker the further out we look into the universe.
Why would it get weaker the further away we look?
Because the further out you look, the less your own motion matters. Imagine you're driving down the road, right? A car right next to you, it seems like it's going really fast compared to you. But a car way off in the distance, it looks like it's moving much slower, even if they're both going the same speed.
Oh, yeah, that makes sense. So a dipole that fades with distance, that's what we should be looking for to prove this whole tilted universe thing. But is there any evidence that this dipole actually exists?
That's the exciting part. The paper points to a bunch of studies that have actually hinted at this kind of dipole. There's this study by Cook and Lindenbell back in 2010, and more recently, some analyses of supernova data, like the JLA catalog and even the Pantheon Plus dataset. They've shown some interesting things.
Wait, Pantheon Plus, that's that huge new analysis of exploding stars they just released to study energy, right?
That's the one. And they found a dipole in the deceleration parameter that actually gets smaller as you look further away, exactly like the tilted universe model predicts.
Wow, that's amazing. So we're not just talking about theory here. There's actual observational evidence that could support this whole tilted universe idea.
It's looking more and more likely. Of course, we need more research to be sure, but it's pretty exciting stuff. It could mean we're on the edge of a major change in how we understand the cosmos.
This is incredible. If something as fundamental as dark energy could actually be an illusion, at least partly caused by our motion, what other assumptions about the universe might we need to rethink?
That's the big question, isn't it? It really challenges us to step back and think about whether our own perspective is shaping our understanding of the universe in ways we never even imagined.
This is what deep dives are all about.
Yeah.
And it sounds like we've got a lot more to uncover. So we've been digging deep into this idea that, our view of the universe might be a little skewed, like literally, because we're moving through space.
Right.
And it's pretty wild, but the more we talk about it, the more it seems like the evidence is adding up, right?
Yeah, definitely. And we've seen how this tilted universe model could maybe explain some of those really weird observations in cosmology, like the fact the universe seems to be expanding faster and faster, and this whole dark energy thing.
Right, right.
And the fact that we're actually seeing things that support this idea, like that dipole in the Pantheon Plus data, it's pretty exciting.
Yeah, no kidding.
Yeah.
This whole thing has really made me rethink, like, everything I thought I knew about the universe. But okay, Let's say we accept this idea that our movement is creating these, like, cosmic illusions. Where does that leave us? Does this mean we have to throw out everything we thought we knew about how the universe works?
Well, not necessarily. It's not like we have to start from scratch. It's more like, imagine you're looking at a painting you've always loved, and then you step to the side, and suddenly you see it in a whole new way.
I like that. So we're not getting rid of the painting, just seeing it from a different angle.
Exactly. And this new perspective, it could change a lot. For example, if the universe's acceleration is at least partly because of how we're moving, then maybe dark energy isn't as powerful as we thought.
So maybe dark energy still exists, but it's not the only thing pushing the universe outward.
Right. It could be that what we see as dark energy is actually a bunch of things combined, like our peculiar velocity, how matter is spread out in the universe, maybe even something about gravity itself that we don't fully understand yet.
That's a pretty big shift in our thinking. But it also opens up a ton of new questions, right? If dark energy isn't the whole story, what else could be shaping how the universe is changing?
That's what cosmologists are trying to figure out now. This tilted universe idea, it pushes us to think outside the box, come up with different explanations and find new ways to test them. And with all these new surveys coming up, like the LSSTDA, which is give us even more detailed maps of the universe than we have now, we're probably going to have a much clearer picture in the next few years.
It sounds like we're about to enter a whole new era in cosmology, where we're not just watching the universe, but really trying to understand how we fit into it, how our own place in the cosmos is affecting what we see.
That's a great way to put it. It's like a reminder to stay humble and remember that we don't have all the answers. Even something as basic as how fast the universe is expanding, it might not be as straightforward as we thought.
It's pretty humbling to think about. It
Yeah,
makes you wonder what other cosmic mysteries are hiding in plain sight, just waiting for us to, figure out how to see them.
exactly. The universe is full of surprises, and there's always more to learn.
Couldn't have said it better myself. And to all of you listening out there, don't forget to check out the show notes for links to all the research we talked about today. Dive in, see what you think, and maybe you'll be the one to crack the next big cosmic mystery.
That's right. Keep asking questions, keep exploring, and never lose that sense of wonder. The universe is a pretty amazing place, and there's always something new to discover.
Well said. And on that note, we're going to wrap up this deep dive. So until next time, keep your minds open and keep looking up at those stars.